So once we find out the concentration at the equilibrium, but we have unknowns in the concentrations. So we would like to find out what is the exact numerical value of this concentration. So what do? Well, in most of the textbooks, it may be at the back or it may be in the chapter, there is a list or a table for the equilibrium constant. And for acetic acid, the Ka is going to be 1.8 times 10 to the negative 5. Now, for this equilibrium constant, it is going to be true at 25 degrees Celsius. If the temperature is changed, then the equilibrium constant would also change. So this is only true at 25 degrees Celsius. Now, how are we going to make use of this constant to find out the x values? Well, first, we would like to write the equilibrium expression. Okay? Before we do any calculations, it is highly recommended that you write an equilibrium expression before you do any math. So to write an equilibrium expression, we have to look at the chemical equation, and we look at the product and the reactants. Based on what we learned, it is always going to be product over the reactant. So now we have the product over the reactant is equal to this number. Okay? And what we do next is simply putting the concentration at equilibrium to these values. So we look at the concentration of CH3COO minus, the acetate ion, it is going to be X. For the hydrogen ion, it is also X. For the acetic acid, we have 0.5 minus X. And that is equal to this equilibrium constant. Now, you may ask, do we have to include any units in the calculation? Well, in the for the equilibrium constant, we do not have any units for the constant. So when we do these type of calculations, we can drop all the units and just put down the number or the unknown in the calculations. So that's the first thing to remind you. Now the second thing is that if we do this, if we try to solve for x, well, the next step is going to be 1.8 times 10 to the negative 5 is equal to x squared over 0.5 minus x. And if you think ahead of how to solve this equation, you will multiply 0.5 minus x to both sides of the equation, and then you will solve it like a quadratic equation, and you will end up using a quadratic formula to solve for this. Now, in chemistry, we would like to try to simplify the process. And to simplify the process, we have to base on one simple assumption. And the assumption based on the x value. Well, if we look at the x value and the k value, now the k value is kind of small. It's 10 to the negative 5. And when we say k value is always product over the reactant, and in this case, we have the x in the product. Now, if k is small and x is on the product side, what we could assume is that the x value is going to be quite small. It is going to be small enough not to affect the difference of the subtraction. So this is a statement that we will always write next to the calculation. We're going to write that assume x is much smaller than 0.5. Okay, so let me go a little bit deeper to this concept. So let's assume that x is a very, very small number, like 0.0000001. If you put it right here, and you do the subtraction, 0.5 minus 0.000001, what's going to happen? Well, it's going to turn out the answer is going to be 0.499999, which is a number that is so close to 0.5. And if you round it off with 2 significant figures or 3 significant figures, it is going to be same as 0.5. So because of the small value of the x, we make this assumption to validate our elimination of the minus x. Now here comes another question. Okay, you can cancel out this x. What happened to this x squared? Now we eliminate this minus x because it has practically no influence on the subtraction right here. But for this x squared, we cannot eliminate the x squared because it has a tremendous effect on the entire calculation. It will make significant changes to the calculation. And because of this reason, we would not be able to cancel that out. So it is going to be x squared over 0.5 is equal to 1.8 times 10 to the negative 5. So we can calculate it. So multiply 0.5 on both sides. You have 9.0 times 10 to the negative 6 is equal to x squared. And then you take the square root on both sides. You have x is equal to 3.0 times 10 to the negative 3. And if you want to express the concentration of each of the ions, then you simply put the x value right here, back into here, and put the units on. So the concentration of the hydrogen ion would be 3.0 times 10 to the negative 3 molar, same as the acidic ion. And if you want to find out the concentration of the acetic acid, you just put that number in here, do the subtraction, you would get your answer. And we can extend this question a little bit by trying to ask, what is the pH of the solution, of the resulting solution at equilibrium? We can simply put this concentration into the negative log, and that is how we get the pH of the resulting solution.